Hi class, moving on to numbers 9 through 14 on our notes for today, which is 5.7. With these problems, the directions are to evaluate each expression. With 10, 11, 12, 13, 14, what we want to do is evaluate them in such a way that our answer is going to be a rational number. It's either going to be an integer or else it's going to be a very easy fraction. And so as we do these, I hate to give you this hint right away, but all of them can be solved using your calculator. However, I don't want you to do these in your calculator right now. I want you to check your work in your calculator after we're all done. With Excel math, I don't want you to do them in your calculator. I want you to follow the math rules that we're going to go through, because you have to know these rules when we get to variables involved. And once variables are involved, you can't do it on your calculator. You have to know the math rules. So please do these along with me, following the rules that I'm going to set before you. So number 9, this just was a very basic example that you learned in the first half of chapter 5, actually probably ones that you learned in intermediate algebra, was that whenever you see a negative exponent, that cannot happen. So you have to bring that to the denominator. So this is just 1 over x squared. Number 9 wasn't anything really big. It's not something that you might see on Excel math as a problem just like this. It just gets you thinking to, oh yeah, that's right. We can't have negative exponents, so how do you change it from negative to positive? You move it from top to bottom or from bottom to top. If it was 1 over x raised to the negative second, well now how do you make the exponent positive? You bring it to the numerator. So you just change it from numerator to denominator or denominator to numerator to make it positive. So our answer for number 9, 1 over x squared. So with that being said, number 10, 16 raised to the negative 1/4. If that is a negative exponent, we can just bring it downstairs, bring it to the denominator to make it a positive 1/4. So now class, when we evaluate these, oftentimes what happens is we just change the form that it's in. Right now, this is in rational form. 16 raised to the 1/4, that's rational form. Let's change this into radical form. When we evaluate, oftentimes we just change the form that it's in and something clears up for us. So if we were to change this into radical form, right now it's in rational form. We want to change to radical form. It would be 1 over the 4th root of 16 raised to the 1st, or just 16. Notice how your index came from the denominator and your numerator became the exponent, like the rules that we had in earlier videos. So I ask you this question, class. Is there a 4th root of 16? Or rather, what is the 4th root of 16? Remember what the 4th root means. It's a number multiplied by itself 4 times that gives 16. Is there a number times a number times a number times a number that gives 16? If you want to see it visually, what times what times what times what is 16? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the 4th root of 16 is the number 2. It is 1 over the 4th root of 16, which is 2. My answer for number 10 is 1/2. Another way that I could maybe explain this that might make a little bit more sense is, let's see, 1 over the square root of 9. We know that it's the same thing. The square root of 9 is 3, right? So it's 1/3. One thing that we can kind of say is it's 1 over the square root of 3 squared. Isn't 9 the same thing as 3 squared? And what happens is if you have the index the same as the exponent, they cancel out. And all you just get is this 1/3. So this right here is the same thing as 1 over the 4th root of 16. And 16 is the same thing as 2 raised to the 4th power. 16 is the same thing as 2 raised to the 4th. So if it's 1 over the 4th root of 16, or 1 over the 4th root of 2 to the 4th, these 4's cancel out, and boom, you get a half. So that's another way that you could look at this if you would like to. Our answer here is 1/2. If you're like very unsure of yourself with these, I think after 11, 12, 13, and 14, hopefully those will give you more confidence as we go forward because we're going to get more practice with these. 243 raised to the 3/5. Oh, there's one more thing I wanted to say. 16 raised to negative 1/4. When you put this into your calculator, you should get 1/2. 16 raised to the negative 1/4. 16 raised to the negative 1/4 is 0.5. And 0.5 is the same thing as 1/2. So as you can see, you can check these in your calculator. Don't do them in your calculator first, please. Follow these math rules and then check your work with your calculator. So 243 raised to the 3/5. This is in rational form. Let's change into radical form. So it's the same thing as the 5th root of 243 cubed. All right, kind of an overwhelming number here. Is there a relationship? And when we're doing problems like this, the skill is to reduce these. So hopefully you can kind of start developing these ideas that, well, the goal is to reduce them. So can I reduce this 243? Is there a number times a number times a number times a number times a number? It's the 5th root. So what multiplied by itself 5 times gives 243? 3 times 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 81. Or 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. So the 5th root of 243 is 3. Or another way you could look at this, the 5th root of 3 to the 5th, we said 3 to the 5th was 243, and it's this value, 243, raised to the 3rd power. So if that's the case, these 5's cancel out, and now all we get is 3 cubed. Our answer is 3 cubed, which is the same thing as 27. Our answer is 27. Or if you don't want to do this whole canceling out thing, I'm just fine if you know, hey, I know what the 5th root of 243 is. The 5th root of 243 is 3. And then don't forget about this cube sign, 3 cubed, which is 27. And by all means, if you want to give yourself a little bit more assurance with these, check them in your calculator. We have 243 raised to the 3/5. 243 raised to the 3/5. Enter, and whoa, I pressed the wrong button. 243 raised to the 3/5. Let's see if that's better. Hey, oh, there it is, 27. So as you can see, 243 raised to the 3/5, we get an answer of 27. Let's practice another one. A negative 32 raised to the 2/5. Now class, there's a big difference between what is written here and between this, a negative 32 raised to the 2/5. If there's a parenthesis, they're saying the whole thing here is a negative 32. What's written, what we have here for number 12, we don't see any parentheses. So what we can kind of say is it's a negative 1 multiplied by 32 raised to the 2/5. So really, class, this 2/5 only goes on to the positive 32 because that 32 is not in parentheses. It's then multiplied by a negative 1 at the end. So let's just do the positive 32. Let's just do this part right here, and then at the end we'll multiply it by the negative 1. So 32 raised to the 2/5. Let's change this into radical form. So radical form would be the 5th root of 32 squared. The 5th root of 32 squared. So now, class, as we've seen in previous examples, is there such thing as the 5th root of 32? Is there a number times a number times a number times a number times a number that equals 32? And hopefully you say it's 2. 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 32 is 2. So my answer is 2 squared. Or not 2 squared, but actually 4. Again, as we've done in other examples, we've said something like this. It's the fifth root of 2 raised to the 5th power, because that is 32, and then it's raised to the 2nd. These 5s cancel out, and now it is 2 squared, which is 4. But remember, class, it's a negative 1 times 32 raised to the 2/5, or it's a negative 1 times 4 times a negative 1 times a negative 1. So what is my answer? It is a negative 4. Let's check it in our calculator and see what we get. A negative 32 raised to the 2/5. A negative 32 raised to the 2/5. The answer is a negative 4. We're doing pretty good. I hope that this is making sense to you, class. We have, is this our last example? We have 2 more examples of this type. So 8 raised to the 3/2 times 8 raised to the 5/2. Remember, class, our rule reminder here, when we have common bases using multiplication, what do we do to our exponents? Hopefully you remember, we add them to get x raised to the 7th power. 2 plus 5 is 7. So we have common bases. What do we do to their exponents? We add them. So we have 8 raised to the 3/2 plus 5/2 is 8/2. 8 raised to the 8/2, which is the same thing as 8 raised to the 4th. This one, there's no changing forms because our answer is basically done once we put it into our calculator, because I don't know what 8 times 8 times 8 times 8 is. We can find it. 8 raised to the 4th. Our answer is 4096. 4096. There's our answer for number 13. All right, number 14. Well, before we do that, let's check it in our calculator. 8 raised to the 3/2. 8 raised to the 3/2. That's this number. That number times 8 raised to the, was it 5/2? 8 raised to the 5/2. So now when I press equals here, I should get the number 4096. 4096. All right, last one. Number 14. 8 27ths raised to the negative 2/3 power. A couple different ways that you could solve this one, I guess. Here's what I think is the easiest. Whenever you have a fraction raised to the negative exponent, this goes downstairs to make it a positive exponent, and this goes upstairs to make it a positive exponent. So now it's 27 over 8. That raised to the positive 2/3. Whenever you see a negative exponent to a fraction, you can just flip-flop the fraction and make it a positive exponent. So now you have 27/8 raised to the 2/3. Now when we have like 2/3 squared, that's the same thing as 2/3 times 2/3, which is 4/9. Or our rule for this, 4/9 is our answer. So our rule for this is we square the top and we square the bottom. So 2 squared over 3 squared, which we get 4/9. So using that rationale, we're going to bring the 2/3 and have the exponent to the 27th and the 2/3 to the exponent of 8. So it's 27 raised to the 2/3 over 8 raised to the 2/3. So now we're going to change this into radical form. It's going to be the cubed root of 27 squared over the cubed root of 8 squared. And once we're here, do you guys know what the cubed root of 27 is? 3 times 3 is 27. So the cubed root of 27 is 3. So now we have 3 squared because this 2 comes along with it. Do you guys know what the cubed root of 8 is? What times what times what is 8? Well, 2 times 2 times 2 is 8. So the cubed root of 8 is 2, and then this 2 comes with it, 2 squared. So our answer is 3 squared over 2 squared, which is 9 over 4. 9/4 is our answer. Let's check it in our calculator. 8 27ths raised to the negative 2/3. 8 27ths raised to the negative 2/3 is 2.25, math fraction, 9/4. Our answer is 9/4, and what did we get? 9/4. So hopefully, you know, as we did these, maybe 10 was difficult, 11 was hard, 12 was moderately hard, 13 was easier, and 14 was hopefully easy. Hopefully that was the progression. Hopefully you got better at this as you went. But by all means, if you need more practice, come to my desk. I will help you out with more of these. I'll give you some more practice problems. You could bring me up your Excel math. I would love to help you out a little bit more to further your understanding.